if you want to calculate refractive index of glass with respect to water, so how can we calculate refractive index of glass with respect to water? I can write NGW, G stands for glass and W for water. We can write here Ng upon NW. So, refractive index of glass divided by refractive index of water. Here we can write C upon Vg. This is the absolute refractive index, speed of light in air divided by speed of light in glass divided by C upon Vw. So, we can write here C and this C will get cancelled, this will go up. So, Vw upon Vg. So, this is the way to calculate refractive index of one medium with respect to another medium. For example, you know refractive index of glass, that means absolute refractive index, is 1.5, that is approximate, that we can write 3/2. Refractive index of water, that is also absolute refractive index, that we can write 1.33, that is equal to 4/3. Now, if we want to calculate refractive index of glass with respect to water, so we can write 3/2, that means Ng divided by Nw is equal to 3/2 divided by 4/3, and here we can take up, that is 9/8. So, this is refractive index of glass with respect to water. So, these are things about the refractive index. Now, see what is the role of refractive index. If you know refractive index of a given medium, you can tell about the speed of light, or you can compare speed of light with the air. But there are certain materials whose mass density is higher, but their refractive index is less. For example, you can see the kerosene and water. Water has got higher mass density, whereas kerosene has got less mass density. But kerosene is considered more optically denser, that means refractive index of kerosene is more than the refractive index of water, whereas water is considered optically denser. So, refractive index also tells us about optical density. Optical density is entirely different with the mass density. So, you cannot say if optical density is higher, it means mass density is also higher. So, by knowing optical density, we can easily find a speed of light in the given media. Okay, we have seen one example in previous clipping. Now, see another example. Light enters from air to glass having refractive index 1.5, it means actually absolute refractive index of glass. What is the speed of light in glass? Speed of light in vacuum is this. So, we can apply formula for refractive index. Refractive index of glass is equal to C upon Vg. We can write Vg is equal to C upon Ng. We know it C is 3 into 10 raised to power 8 meter per second, and Ng is 1.5. So, we can write basically here, remove the decimal from here, put 10 here, this is 15 and 2. You are getting 2 into 10 raised to power 8 meter per second. So, this is the speed of light in glass, which is less than the speed of light in vacuum. Now, see what is refractive index, what is the unit of refractive index actually? As you have seen, refractive index is a ratio of two same quantities, it has no unit, it is just a number which tells us about optical density. Now, we will see refraction of light through a glass slab.